Now we will discuss one by one all our data communication devices, communication media, and communication network architecture from the slides. Data communication devices. Networking hardware includes all the computers, peripherals, interface cards, and other equipment needed to perform data processing and communication within the network is called called data communication devices. Mostly we see the following number of devices: workstations that are sometimes we call source and destinations, hubs, bridges, firewalls, routers, file servers, repeaters, amplifiers, modem, and so many other devices. Basic hardware components for networking. All networks are made up of basically hardware building blocks to interconnect network nodes such as network interface cards, NICs, bridges, hub, switches, and routers. In addition, some method of the connecting these building blocks is required, usually in the form of cables. Most commonly, category 5 cable, that is Cat 5, Cat 6, Cat 7, and wireless. These days we are using, instead of Cat 5, Cat 7, Cat 7, and Cat 8 type of cables. This is the type of cables we used when we are using wire network, and also we are using wireless communication as well. So first, hardware devices, we have network interface cards. A network card, or we can call it network interface card, NIC. This is sometimes we call we ask such type of things in our MCQs as well, that NIC stands for what. So students write down their name that it is national identity card. No, it is not national identity card. It is network interface card. So NIC is a piece of computer hardware designed to allow computers to communicate over a computer network. It provides physical access to a networking medium and often provides a low-level addressing system through the use of MAC addresses, as I have already discussed, that machine addresses and IP addresses, because directly physical wired or wireless medium is going to be connected by the help of RJ45 connector. The cables and the wires are we used to connect on this particular networking device we call NIC, network interface card, or sometimes we call it LAN card. It allows users to connect to each other either by using cables or wirelessly. The NIC provides the transfer of data in megabytes. These days we have gigabytes in GBs as well. Gigabyte. This is actually network interface card, and you can see in this network interface card here you use twisted UTP or STP wires connected with the help of RJ45 connector. This is female connector of NIC, in which you connect the male RJ45 connector over here. Data communication over standard telephone lines, for which we use a device we call modems. Most telephone lines attached to home and business are analog, not digital. Because PC transmit and receive data in a digital format, a device called modem is needed to convert digital data to analog format for the transmission over phone lines. When receiving data from another computer at the destination, the modem converts it from analog format to digital format so that that message can be received at the destination. So you can see this is a digital data. It is converted, that is modulated and transmitted with the help of telephone lines. And there is another modem available at the destination, which demodulates that analog signal into digital, so that this hello message which is transmitted is received at the destination. So this modulates, that is digital to analog, and this demodulates, that is analog to digital. Repeaters. A repeater is an electronic device that receives a signal and retransmit it at a higher power level or to the other side of an obstruction, so that signal can cover longer distance without degradation. In most twisted pair Ethernet configurations, repeaters are required for cable runs longer than 100 meters away from the computer, as I have already discussed with you. You can see source, destination. So after 100 meters, if destination is not achieved after 100 meters, so it might be possible that the signals is going to be die out or degrades. So we connect repeaters which regenerates the signal, so that it can further travel at a far distance. And if in next 100 meters the destination is available, so there is no need of any repeater. But if the destination is still far away, so we can use some more repeaters in between the source and the destination. Hub, as I have already discussed with you, I have given you the summary of hub. A hub contains multiple ports. When a packet arrives at one port, it is copied to all the ports of the hub for transmission. Hub works at physical layer of the OSI, Open System International Model, which is the lowest level. This in lecture number 5, I have discussed with you the OSI structure. So it is the lowest level of physical layer, is the lowest layer of OSI model. Hub has one collision domain, and hub has one broadcast domain, that it only broadcasts flood, and it does flooding and forwarding of information. So if it takes more number of consumes more number of bandwidth, if it does not if hub wants to transmit data from PC number 1 to PC number 7, and if it does not flood out the data for to all the ports, then all other ports can communicate or perform their own required tasks instead of waiting for the message on the dedicated links or the bandwidth, or which is not actually belongs to them. So it actually wastes their time, and in this way occupied more number of bandwidth. You can see there are different ports available. If this wants to send a signal to this one, it is flooded to all other devices as well. Switches is a device that performs switching, especially it forwards and filters the OSI layer to datagrams. Switch forward frames based on the MAC address. A switch is used to segment a network. It can segment out the network. It can easily learn the IP address. Some switches are capable of routing based on IP addresses, that is Cisco layer 3 switches. But again, if it is Cisco layer 3 switching, that it means that that switch is having the capabilities of routing as well, but the main duty of switch is to just not to perform the routing, but to provide the communication of the local area network devices. But in new era, switches have some more number of tasks that instead of using a router, sometimes with the help of switching, we have some additional add-on features in layer 3 switches that they are capable enough to do routing as well. So here you can see different types of switches having different amount of ports available. You can add more number of ports because some switches are having the extension ports. You can add more number of ports. Bridges. A bridge is a device that allows you to segment a large network into two smaller, more efficient networks. If you are adding to an older wiring scheme and want the new network to be up to date, a bridge can connect the two networks. So if this is local area network one of my local area network A and this is my local area network B, so if I want to balance the load that the communication speed remains okay over here as well and over here as well, so I can balance it with the help of a bridge can while these networks are willing to communicate within their own local area network, so there is no need to every time send the information or share the information with a large number of destination. So they it only knows that we have only some smallest number of pieces available with its devices. But sometimes if this local area network wants to communicate with this any of the device available in the local area network B, then bridges smoothly help out in order to provide a smooth and fastest communication from LAN A to LAN B. So in this way, it actually balances two different segments. Or if you have a larger LAN, so you can segment out your larger LAN into two smaller LANs so that the communication speed remains same and you do not have a degraded performance or your network speed is slower down. So you can see this is port LAN A and LAN B, and some computers we have some devices we have in LAN A and LAN B, and if any device of LAN A wants to communicate with LAN B, we have a speediest device we call bridge. With the help of this network can easily communicate with the 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 other local area network. But as I have discussed with you, as I told you before, that bridge is for the same type of network. We have divided the same large network into two smaller local area network, but these networks are our own networks. And as compared to router and bridge, a router is a device which provides communication between two different networks. One is your domain network, another is any other domain network. But here, both are your domain network. This also belongs to you, and this also belongs to you. So bridge is connected within the same domain network, but in order to balance the larger network, it segments out in the larger network into two smaller networks. So you can see segment 1 and segment 2, and with the help of bridge we have easily balanced a large network. So a bridge monitors the information traffic on both sides of the network so that it can pass packets of information to the correct location. Most bridge can listen to the network and automatically figure out the address of each computer on both sides of the bridge. The bridge can inspect each message and, if necessary, broadcast it on the other side of the network. If one side is willing to communicate with other side, it broadcasts and it is it reaches to the device for which the message is actually transmitted. The bridge manages the traffic to maintain the optimum performance on both sides of the network. As I discussed with you, it helps you to maintain the performance of the network communication and network speed. You might say that the bridge is like a traffic cop at a busy intersection during rush hours. It keeps information flowing on both sides of the network, but it does not allow unnecessary traffic through. You got it? So it try to control the unnecessary traffic data. Bridge can be used to connect different types of cabling or physical topologies. They must, however, be used between network within the same protocol. As I have already discussed with you, that it is used within the same domain, that is your own domain. Same type of protocols were used. Routers. Routers are networking devices that forward data packets between networks. Routers work at the network layer of OSI model, which is third layer network layer. Last layer is physical from the bottom. Then second last data link layer, and then we have third network layer. So router uses logical addresses, addresses we call. Router select the best path from its routing table to forward the packets to remote destination. And the most important definition or the concept to understand about a router is a device which connects two different networks. At one end of the router we have one network, and at the other end of the router we have another network. So it connects two different domains actually, your domain to the other domains, through which you can avail the internet facilities. Example, it is mainly used by internet. So mostly you use routers to access the internet services. So this is a device, router. The telecommunication system and all the communication system devices which helps to transfer the data from source to destination comes under the communication devices. The hardware and the software that transmit information from one location to another. Components include hardware, media, that is cables, networks, software. Sometimes we have different types of networking softwares, communication providers, protocols, set of protocols, rules of protocols is actually the rule communication rules, TCP, that is transfer control protocol, FTP, file transfer protocol, and applications. Telecommunication signals are mostly analog, that is continuous waves, information conveyed by changing wave characteristics, amplitude, and frequency. Then we have digital signals, discrete pulses, information conveyed in binary form, 0 1 1 0 0 1 on and or off pulses, easily understood by the computers. Communication processor, hardware devices. We have some more networking data communication devices in which we have communication processors. So hardware devices utilized in data transmission and reception. Modem, as I have discussed, device that converts analog signal to digital and vice versa, enables signals transmission over telephone system. Multiplexers are the devices that transmit multiple signals over a single medium. It multiplexes many signals to travel on a single medium. Front end processor, these are the processor specialized computer dedicated to managing communication tasks. In order to provide smooth communication, we have front end communication processors. Then we have our second topic, that is transmission media. So basically our transmission media is divided into two. One is wired, which we also call guided, and wireless unguided. Data transfer over the network is through some media classified into cables, satellites, wireless, as I have discussed with you.